Hello everyone, Mr. Eisinger here. This is a Unit 1 introductory video for the AP Physics C Mechanics course. This unit is aligned with the AP Board's suggested unit called Kinematics, or what I typically call the mathematical model of motion. Now you may have heard that mathematics is the language of physics. In this first unit, we'll lay the mathematical foundation upon which many physical laws rely, especially as we study Newtonian mechanics. The unit will cover topics found in chapters 2 and 3 of your textbook. And in this first video, I'm going to simply outline the various topics that we'll explore throughout the unit. Now, this first unit deals very little with any actual physics. There are no scientific laws, there's no theories being presented here. You'll see that many of the topics presented in these first two chapters anyway are covered in detail in your higher level math classes. Some of you may need only to review these topics while others may still be in the developmental stage. Regardless of where you fall, you're going to see much overlap between your math classes and this first unit. Let's take a look at the topics in Chapter 2. We'll start by looking at reference frames and displacement. We'll move on to average velocity. We'll use a little bit of calculus to develop this concept called instantaneous velocity. Acceleration is a conceptually challenging quantity to understand. We'll develop sort of a conceptual understanding of it as well as look at it mathematically. Motion at constant acceleration, we'll see some equations that can be used to describe objects accelerating uniformly. It's pretty much a staple of Unit 1. We need to understand these equations and apply them pretty well. We'll develop some problem-solving strategies, particularly valuable when we look at complex problems dealing with constant acceleration. Falling objects is the key scenario that we'll use to apply the constant acceleration model. And then graphical analysis of linear motion. We'll look at how we can do a lot of interpretation of what's going on by looking at graphs. Your math classes, particularly calculus, does a pretty thorough job of that, so you're going to see some overlap there. Chapter 3, we look at kinematics in 2D or 3D, so we'll take the concepts from Chapter 2 and apply them here. We need to understand this quantity called vectors. So we'll start by looking at vectors and scalars. We'll do some addition of vectors. We'll look at graphical methods to begin with. We also need to be able to subtract vectors, both graphically as well as mathematically. We'll show you what that means from a physical standpoint and look at its implications. Scalar multiplication is another thing we can do with vectors, and we'll show you how to do that. Mathematically, we can add vectors by using components, and so we'll probably rely on this quite a bit since we're all pretty good with math. It's a much more accurate way of dealing with vector addition than graphical methods. We'll look at unit vectors as a convenient way of organizing these vector quantities. Vector kinematics, again, is just a connection between Chapter 2 and 3. Projectile motion, the key scenario in which we will apply these concepts for Chapter 3. And then we'll, again, develop some problem-solving strategies, particularly in the area of projectile motion. And then we'll finish up the unit by looking at relative velocity. And there we go, a quick overview of Chapter 2 and 3.